Hello everyone. Today we'll be discussing about Bayesian estimation. So, Bayesian estimation on process produces not a single point estimate for the best value of the regression coefficient, but an entire posterior distribution, completely describing the uncertainty surrounding the quantity. This can be used to estimate the best coefficient using the mean, mode, median, any quartile, or any other functions of the posterior distribution. Bayes rule. What Bayes rule says? Probability of theta given x is true equals to probability of theta multiplied by probability of x given theta is true divided by probability of x, where theta and x are the events and probability of theta and probability of x are the independent probabilities of theta and x respectively. So what is generative model? Generative model is a class of model for the unsupervised learning where given training data, our goal is to try and generate new samples from the same distribution and then train model to generate data like it. Estimating the parameters of a distribution discrete case. Xi to the power t equals to 1 if an instance t is in state I. Probability of state I is Qi. Dirichlet's prior. Dirichlet distribution is a way to model random probability mass function for finite sets, and the Dirichlet distribution also sometimes used as prior, as in this case, in Bayesian statistics. Alpha I are the hyperparameters. What the formula is? Dirichlet Q given alpha equals to gamma of alpha 0 divided by gamma of alpha 1 to gamma of alpha k. The limit of I equals to 1 to k of qi to the power alpha I minus 1. Sample likelihood. Probability of x given q equals to limit of t equals to 1 to n, limit of I equals to 1 to k of qi to the power xi to the power t. Posterior. P of q given alpha equals to gamma of alpha 0 plus n by gamma of alpha 1 plus n to gamma of alpha k plus nk. The limit of I equals to 1 to k of qi to the power alpha I plus ni minus 1. This is equals to the Dirichlet of q given alpha plus n. Dirichlet is a conjugate prior with k equals to 2, Dirichlet reduced to beta. Estimating the parameters of a distribution continuous case. The normal distribution with mean, mu and variance alpha squared, we say that a random variable x has the normal distribution with mean, mu and variance alpha squared given as p of x to the power t tends to n of mu comma alpha squared. The Gaussian prior for mu given p of mu tends to n of mu 0 comma alpha 0 square. Posterior is also Gaussian. P of mu given x tends to n of mu n comma alpha n square, where mu n equals to alpha square by n alpha 0 square plus alpha square of mu 0 plus n of alpha 0 square divided by n alpha 0 square plus alpha square of m. 1 by alpha square equals to 1 by alpha 0 square plus n by alpha square. You can see that P of mu is this graph. P of mu given by x is this, which is the taller among the three, and P of x given mu is this one. It's a little wider than the other curves. So why Gaussian? Gaussian distribution are widely used in machine learning for central limit theorem. Gaussian are convenient computationally. Mixture of Gaussian are sufficient to approximate a wide range of distribution closely related to squared laws and important error measured in statistics. These are the importance of Gaussian. Estimating the parameters of a function regression. R equals to W to the power T x plus epsilon, where P of epsilon tends to n of 0, 1 given beta and P of R to the power T given x to the power T, W, beta tends to n of W to the power T x to the power T, 1 given beta. Log likelihood. L of R given x, W, beta equals to log the limit of t of probability of R to the power t given x t, W, beta equals to negative n log of root 2 pi plus n log beta minus beta by 2 summation of t of R to the power t minus W to the power t x to the power t. ML solution of W ml equals to x to the power t multiplied by x, the whole of negative power of multiplying x to the power t and r with it. Gaussian conjugate prior is equals to p of w tends to n 0, 1 given alpha. Posterior p of w given x tends to n of mu n and summation n, where mu n equals to beta summation n x to the power t r summation n equals to alpha I plus beta x to the power t of x to the power minus 1. So this slide explains the graphical image of prior and posterior when alpha and beta differ from each case. So first let's talk about the first one. It's alpha 1, beta 1. The image of prior is this and the image of posterior is this. Moving forward to the next case, alpha is 10, beta is 2. You can see the image of prior and the image of posterior. When alpha and beta is almost same, it's not almost, it's same, alpha equals to 1 and beta equals to 1. The image of prior is this, which is almost similar to the first case, and the posterior is also quite similar with the first case, but it's a little bigger than the first one. Basis of kernel function. Kernel function is a popular function used in various kernelized learned algorithm. In particular, it's commonly used in support vector machine classification. For new x dash, the estimator r dash is calculated as r dash equals to x dash to the power t equals to beta x dash to the power t summation of n of x to the power t r equals to summation of t beta of x to the power x dash to the power t summation n x t r t. This is called dual representation. Linear kernel r dash equals to summation of t beta x dash to the power t summation of n x to the power t r to the power t summation of t beta k of x dash comma x to the power t of rt. For any other psi x, we can write k x dash x as to psi x dash to the power t of psi x. This slide shows about the kernel function graph of linear, quadratic, and fourth degree of same value of alpha and beta. For alpha equals to 1 and beta equals to 1, then linear graph is like this. The quadratic graph is a little bit slanted, it's different. And the fourth degree graph is like a curve. Not a curve properly, but not at all a straight line. It's increasing and then it's moving like this. Gaussian processes. Assume Gaussian prior P of W given n of 0, 1 given alpha y equals to xw, where e of y equals to, this is a matrix, okay, equals to 0 and covariance of y equals to k, with kij equals to xi to the power t of x to the power I. K is the covariance function here, linear, with basis functions phi x comma xij equals to psi x to the power I to the power t is the whole power of t of psi x to the power I. R tends to n 0 comma cn, where cn equals to 1 by beta of I plus k, with nu x dash as added as x n plus 1 comma r n plus 1 tends to n plus 1 0 comma cn plus 1. This is a matrix of cn plus 1 where r 1 1 equals to cn, 1 2 equals to k, 2 1 equals to k, and 2 2 equals to c, where k equals to k x dash comma x t of t to the power whole t, and c equals to k x dash comma x dash plus 1 by beta p of r dash given x dash comma x comma r tends to n give of k to the power t of c n minus 1 r comma c minus k to the power t of c n minus 1 k. So this explains the diagram of linear, quadratic, and Gaussian, where alpha equals to 1 and beta equals to 5. So this is a linear graph, this is a quadratic graph, and this is the Gaussian graph, like a sine wave. Thank you.